Okay, so in this chapter we're going to start talking about right triangle trigonometry. Trig is one of the important fundamentals of math that you're going to see going forward in all of your classes. You have some exposure to SOHCAHTOA from your geometry and algebra 1 courses. It might have been a while, but I'll be honest with you, one of the biggest things that is a bit of a savior is the idea of SOHCAHTOA. And so really we can find information about triangles and relationships between angles and sides by doing the idea of sine is equal to the opposite side of a triangle. And we'll do more with these examples, but if you remember, it's opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent, run out of room here, is equal to opposite over adjacent. Okay, so remembering this is a huge help when we're dealing with right triangle trig. And using SOHCAHTOA, we're dealing with right triangles. Okay, you can follow along in your book if you want, and I got a couple things here. And we got a few things that we're going to do here. If you want to follow along in your book, that's fine. If not, it's not necessary. And so I'm going to go ahead and look at this triangle. I'm going to say, okay, well, it's a right triangle, and this is a 5 on one side and a 12 on the other side. Well, I know my triples, and I know in your honors geometry courses you spent a lot of time on triples. So we should know that that's 13. And if you don't know, you can just use Pythagorean Theorem. And Pythagorean theorem is a squared plus b squared is equal to c squared. And so I'd do 5 squared plus 12 squared is equal to c squared. I'd get c squared is equal to 169, and then c would equal 13. And hypotenuse is always positive, so we don't have to worry about the plus or minus when we take the square root. And so now what we're going to do is we're just going to write each ratio and then find its nearest value to the 10,000ths, which is 4 decimal places. So you have to be careful with rounding when I ask you to round. So these guys on the right here, we're going to talk about these in a second, but really sine is equal to opposite over hypotenuse. So I know sine is equal to opposite over hypotenuse. And so the opposite side, and notice I'm looking at angle B, so it's all relative to the angle. So here's angle B, so this guy is the opposite side, and the side opposite the right angle is always the hypotenuse. And so all I'm doing is I'm taking the fraction of the opposite side over the hypotenuse. And that's approximately 0.9231. So we're going to do the same thing here. We're going to focus on the same angle, so we're focusing on angle B. So cosine of angle B is adjacent. Adjacent is next to. So we're going to have 5 over 13, which works out to approximately 0.3846. So all we're doing is taking the fraction of the sides, okay? And so now tangent of B, so we're not even really using the calculator other than to evaluate the fraction, okay? So tangent of B is opposite over adjacent. Let me write an adjacent right here. So opposite is 12, adjacent is 5, and so that ratio gives me 2.4, okay? So now these guys right here, these are the reciprocal trig functions. Okay, so the reciprocal trig functions, reciprocal, they're just flipped, right? So all we have to do now is take our fractions and flip them. So cosine is 13 over, or excuse me, cosecant, and I'll write these next to it. Abbreviations are fine. It's 13 over 12. Secant is 13 over 5, and cotangent is 5 over 12. And these decimal values, once again, just crank it out on your calculator, is this one's 1.0833. Next one is 2.6. And then the last one is 0.4167. Okay? And I'm going to go ahead and shrink this down. And I'm just going to write the 6 trig functions and their side relationships, their side ratios. So sine of angle B, or any angle for that matter, so I don't have to put any letter there, but sine of any angle is going to be opposite over hypotenuse. Cosine of an angle is going to be adjacent over hypotenuse. Tangent of any angle is opposite over adjacent. Now these I didn't spell out because I spelled them out in the previous one. I'm going to spell these guys out. So cosecant, and right across from sine is its reciprocal trig function. So cosecant of an angle is going to be hypotenuse over opposite. Secant, and you might remember secant lines from your geometry class, is going to be hypotenuse over adjacent. And then cotangent of an angle is going to equal adjacent over opposite. And so quite frankly, all I do is I remember these, and then I know that it's a reciprocal relationship. Okay? And that's how I remember all these guys. So this is the basic setup of dealing with the trig ratios. Okay? We're going to do a little bit more with some of the reciprocals and different ways that we can look at them, but this is straightforward, like what sine, cosine, tangent, and reciprocal relationships, and that's it. Okay? And so that question right here is, what type of relationships are they? They're reciprocal relationships.